we are trying to show that the angle PSR is equal to half the distance of the measurement of arc PQR and PR here. So the first thing that we want to do for this proof is to draw a line segment from S to Q. And notice that this line segment does intersect the circle here, and we've noted that at point T. So what this does is it essentially divides the angle into two different angles. So now we know that the angle PSR is equal to the sum of angle PSQ and QSR. Similarly, we can say the same for the arcs. So the arc PQR is now equal to the sum of PQ and QR, and the arc PR is now equal to the sum of arc PT and arc TR, and I will have that information here. So from theorem 2, we know that the angle PSQ is going to equal half the difference of the arc PQ minus arc PT, and the same can go for QSR. So we have this, and that's where this information comes from here. Now, if we substitute this, we see that this sum here, we can put these measurements in. So we substitute that into our equation, and we get that the angle PSR is now equal to the sum of the two differences of the arc measurements. So notice that here we have two positive arc measurements, and then these are technically negative arc measurements. However, we know that measurements are not negative. It just means that they are being subtracted. So here what we would do is just rearrange these measurements that we have, and we'll find that 1/2, we take out the common factor 1/2, and so this angle PSR is now equal to half of the sum of arc QR plus arc PQ, and then we subtract the sum arc TR and arc PT. However, notice that this is what we have here for our measurements of arc PQR and arc PR. So we can substitute that in, and we see that we ultimately get the equation 1/2 of the arc of this difference of arc PQR and arc PR. So this shows us that the angle PSR is equal to this difference here, and thus proving the theorem.